Hello everyone, we're going to be going over section 5.7, which is on dividing a polynomial by a monomial. So remember this idea of a monomial we talked about before. It's a polynomial with just one single term, so we give it a specific name of a monomial. So our objective is just that we want to divide a polynomial by a monomial. So moving on to this objective, we want to recall that when we add fractions, they must have the same denominator as follows. If we want to add a divided by c plus b divided by c, they have the same denominator, so we can go ahead and add them. And when we do, it becomes a plus b divided by c. So this statement holds also in reverse. This means that we can take a plus b divided by c, and we can separate it into a divided by c plus b divided by c. So the statement holds in reverse, and it gives our rule for dividing polynomials by monomials. So when dividing a polynomial by a monomial, in order to divide them, you want to divide each term of the polynomial by the monomial. So if you have a plus b divided by c, you separate that into a divided by c plus b divided by c, where c is not 0. So some examples would be if we had 2 plus 5 divided by 3, we can separate this to 2 divided by 3 plus 5 divided by 3. And also if we have something like x plus 3z divided by 2y, we can separate this into x divided by 2y plus 3z divided by 2y, where y does not equal 0. And then parts of a division problem are named below. So sometimes we'll refer to certain parts of a division problem. So whenever we have something or the numerator being divided by something else, the denominator, our numerator is referred to as the dividend, and the denominator is referred to as the divisor. And then once we get their answer, the answer there is called the quotient. So just as we call the sum when you add two things together, the quotient is when you divide two things. So all right, let's go ahead and do a problem together. So example 1, we want to divide 5m to the power of 5 minus 10m to the power of 3 by 5m squared. So in order to divide we can put them into fraction form with 5m to the power of 5 minus 10m to the power of 3 as the dividend, and 5m to the power of 2 as the divisor. So we're dividing 5m to the power of 5 minus 10m to the power of 3 by 5m to the power of 2. So when we write that out, we'll get 5m to the power of 5 minus 10m to the power of 3, all by 5m squared. And so what our rule that we learned allows us to do is that it allows us to separate our I really want to call it quotient, but we're just dividing our problem into two separate pieces. So we're taking this 5m to the power of 5 divided by 5m to the power of 2. And then we're subtracting 10m to the power of 3 by 5m to the power of 2. So we see this overlapping occurring. So we write 5m to the power of 5 divided by 5m to the power of 2. And you want to keep whatever operator you had. So we had 5m to the power of 5 minus 10m to the power of 3. So we're keeping the subtraction symbol. So minus 10m to the power of 3 divided by 5m squared. So now we have this new equation here. We basically have two areas where we're dividing. And now we can simplify our expression. In our first term, we have 5 divided by 5, and we're really just using our quotient rules for exponents at this point with coefficients. So we can separate this into 5 divided by 5 times m to the power of 5 divided by m to the power of 2 minus 10 divided by 5 times m cubed divided by m squared. So we can simplify this further. We know 5 divided by 5 is just going to be 1. And then we can rewrite m to the power of 5 divided by m to the power of 2 of m to the power of 5 minus 2. Then we have 10 divided by 5 is 2. And we have m to the power of 3 minus 2. And so now we just need to simplify. So we don't need to include the 1 in our first term. We're going to have m to the power of 3 minus 2m. So this is our final answer here, and this is our resulting quotient. So this is our resulting quotient. We just want to check and make sure that this is correct. And to check and make sure that this is correct, we're going to take our quotient and we're going to multiply it by our divisor. So we can say, to check your answer, we can multiply our quotient by the divisor. So let's go ahead and check and make sure that this is correct. So we're going to check, we're going to take 5m squared, our divisor, and we're going to multiply it by m cubed minus 2m. So when we multiply these values together, we're going to distribute, so we're going to have 5m squared times m to the power of 3, so we're just adding exponents in this case. So we get 5m power of 5. Then we have minus 5m squared times 2m. 5 times 2 is 10, and you add the exponents of m to get 10m to the power of 3. Which is correct. So now we know for sure that our answer is going to be m cubed minus 2m. So all right, let's go ahead and do a harder problem now. So now for example 2, we want to divide, and we have a much longer equation. But we want to do the same thing as we did before. We can still use our rule. A plus b divided by c is the same thing as a over c plus b over c. We can still use this rule. No matter how many terms we have in the numerator. So we can do this for as many terms in our numerator as we want. It doesn't have to be just 2 terms. So taking our original problem here, and we're going to take each term and we're going to divide by negative 30xy squared. So the equation that we have here is 180 x to the 4th y to the 10th minus 150 x to the 3rd y to the 8th plus 120 x squared y to the 6th minus 90 xy to the 4th plus 100y, all divided by negative 30 xy squared. All right, so let's go ahead and start separating out this equation. So our first term is 180 x to the 4th y to the 10th, which we're dividing by negative 30 xy squared. Now we'll subtract off our second term because we're going to keep these operators the same. We can keep these operators the same, or if you'd prefer it, you can change each subtraction to adding a negative instead if you want to keep everything to be, if you just want to keep everything to be addition. If not, then you just want to keep the operators the same. So I'll write our next term, which is going to be 150 x cubed y to the 8th divided by negative 30xy squared plus 120 x squared y to the 6th divided by negative 30xy squared minus 90 xy to the power of 4 divided by negative 30xy squared plus 100y divided by negative 30xy squared. All right, so we've separated out our equations here. Now we want to simplify as much as possible. So we can divide out our coefficients. So our first coefficients here will be 180 divided by negative 30. Then we also have x to the power of 4 divided by x, and y to the power of 10 divided by y squared. So this can be considered our first term. And if we want to save some space, we can combine our x's and y's. We don't have to separate them out. Minus, and then we're going to take 150 divided by negative 30, and x cubed y to the 8th divided by xy squared, plus 120 divided by negative 30. Oh, very smushed together there. Here we are. Times x squared y to the 6th divided by xy squared minus 90 divided by negative 30 times xy to the power of 4 divided by xy squared plus 100 divided by negative 30 times y divided by xy squared. All right, so we've separated our variables from our coefficients. Now let's focus on dividing out our coefficients and rewriting our variables. So 180 divided by negative 30 is going to give us negative 6. We see x in our numerator has the power of 4, x in our denominator has the power of 1, so we're going to have x to the power of 4 minus 1. We do the same thing for y, so we get the power of 10 minus 2. Minus 150 divided by negative 30 is going to give us negative 5. Subtract our powers in the numerator, we'll get x to the power of 3 minus 1 and y to the power of 8 minus 2. 120 divided by negative 30 is going to give us negative 4. And then subtracting exponents, we get x to the power of 2 minus 1, y to the power of 6 minus 2. 90 divided by negative 30 is going to give us negative 3. Our x's are going to cancel out since we see we have an x to the power of 1 minus 1. And then we have y to the power of 4 minus 2. And lastly, 100 divided by negative 30 does not divide evenly. It's going to end up giving us negative 10 divided by 3 times x to the power of negative 1, because this is technically 0 minus 1, and y to the power of 1 minus 2. So more rewriting in this case. Our first term is still going to be negative 6, but now we have x to the power of 3 and y to the power of 8. We have a double negative here, so we can change this to plus. So we're going to say plus 5x to the power of 2, y to the power of 6. We have plus a negative, so we'll say minus 4x, y to the power of 4. We have another double negative, so we'll write this as plus 3 x to the power of 0, so we just want to write it, and y squared. And lastly, we have plus and negative, so we'll say minus 10 over 3. And since we have x to the power of negative 1, our x is going to go in the denominator, and we're also going to have y to the power of negative 1, so y is in our denominator as well. And this here would be our quotient. This would be our quotient from dividing our very large polynomial by a monomial. So something important to notice here is that our quotient is technically not a polynomial. And we'll explain why here. So this quotient is not, and let's write that large not, let's highlight it, not a polynomial. Because our negative 10 divided by 3xy has variables in the denominator. Polynomials are only considered polynomials when the powers of the variables are whole numbers being 0 to infinity and nothing in between. It has to be the whole number. So we're not considering negative exponents. So that means that we can't have variables in our denominators. So that means that our quotient is a quotient, but it's not a polynomial. And another note we can make here is that the sum, difference, and product of polynomials are always polynomials. But the quotient of two polynomials may not be. So when dividing polynomials and monomials, polynomials, binomials, anything along those lines, whenever you're dividing, your quotient or your result doesn't have to be a polynomial. But if you're ever finding the sum, difference, or product of polynomials, your answer will be polynomial, just not when you're dividing. So, all right, that wraps up our section 5.7 here with dividing polynomials by monomials. So I'll see you again in the next lecture.